Hey guys, Zong here, back with another math video. Today we're going to be tackling some coordinate geometry. So, look at the problem. I drew the graph out for you to make it a bit easier. So, look at the problem and try to solve it. Okay, time for the solution. So, this graph is basically, the equation of this graph is y equals natural log of x. Oh yeah, caution, I'm not using my drawing tablet, I'm using a mouse, so yeah, my handwriting is going to be very bad. Okay, so this is the equation of the line, right? And we want to find x3, or the x coordinate of E, right here. So how do we do that? So, we begin by seeing that, well, if we want to find the x coordinate v, we should probably find the y coordinate v, which might be a bit easier than directly finding the x coordinate v. And we realize that they gave us sort of a hint, because C is directly horizontal to E, and thus C has the same y coordinate as E. So we find the y coordinate of C, we should find the y coordinate of V. So how do we get there? Well, first, let's draw some lines. We see that since these trisect it, basically, if you draw these lines, you'd see that they are all part of the, oh sorry, not those lines. Yeah. Basically, that you'd see that these are all similar triangles. And this is important because C and D trisect A and B. So AC is 1/3 of AB, and CD is 1/3 of AB, and BD is 1/3 of AB. And since these are all nested triangles, this small triangle is similar to this large triangle, and since this hypotenuse of the small triangle is 1/3 of the hypotenuse of the large triangle, the height of this small triangle is also going to be 1/3. And thus, this medium-sized triangle, its height is also going to be 2/3 of the height of this larger triangle, because they are nested triangles and they're similar, and the hypotenuse is 2/3 the length of this large hypotenuse. And because of that, since this part right here is 2/3, this part is 1/3 the height of the large triangle. And because this is 1/3, this height right here is just the y coordinate of C, because it's how high C is above the x-axis. So if we can find this sliver right here, we can find if we can find the y coordinate of B. Okay, y coordinate B is the height of this large triangle, and we know that the height of this little line right here, the y coordinate of C, is 1/3 the y coordinate of B. Then we can just find the y coordinate of C if we find the y coordinate of B. So, okay, to make this clear, let's just start by finding the y coordinate of B. And we're given that x2 is 1000, so y2 is just equal to natural log of 1000, and that is the y coordinate of B. And we just saw before, because of similar triangles, the y coordinate of C, which is just this, which is the same as this, is 1/3 of the y coordinate of B. So that 1/3 of that natural log 1000. And if you watched our log videos, you know that this is equal to natural log of 1000 to 1/3. You should watch our log videos. It's just a property of logs. If the coefficient is, you can just move it to make it the exponent of 1000 and stuff like that, which is equal to natural log of 10. Okay, that's great. So again, to make it clear, the y coordinate of C is just 1/3 the y coordinate of B, because of similar triangles, and because C and D trisect this line. So I hope that's clear. So we know the y coordinate of C is natural log of 10. Well, that would also be the y coordinate of E, as we said before, since they lie on a horizontal line. The y coordinate of E is also just natural log of 10. So we want to find the x coordinate of E, and since E lies on the line y equals ln, or natural log of x, then we know that y3 equals natural log of x3, and thus natural log of 10, since natural log of 10 is the y coordinate of E, which is equal natural log natural log of x3. Gene's x3 would just equal 10, because, you know, natural log of 10 is natural log of x3, so x3 equals 10. And that's our answer. So basically, the thing we learned from this problem is that it's important to visualize normal geometry within coordinate geometry, because coordinate geometry can kind of intimidate you with its points and random equations and stuff, but really it's just a different form of normal geometry, and when you get to visualize that, you can easily solve the problem. Like here, we made similar triangles out of a graph. So yeah, thank you, and I'll see you next week. Hey guys, I'm here back with another math video. Today we're going to do AIME 2006 number 2, number 5. It's a probability problem, and regularly probability problems turn up a lot in AIME, so I decided, why don't we practice some probability today. And just so, look at the problem, read it, pause the video if you need to,